Hello, John and Oscar Fields here again. We're going to make our third video, start on it tonight. And what we have here is a pretty rare amp. It's a mid to late 60s Peavey musician. It's the first musical instrument amplifier that Peavey offered for commercial sale, as far as I know. I could get someone to check on that for me, but it's in fairly clean shape. You know, it's a little bashed up, got some paint on it. Anyways, we're going to open this amp up and dig into it and see if we can't figure out why it's not working, and hopefully learn a little bit about the really early Peavey amplifiers and what went into them. Maybe a little bit about how to identify the different schematics that you might need for the different versions, because when these amps came out, they were just kind of some of the first amplifiers that had solid state transistors in them that were fairly high powered. This one has two RCA 40411 outputs, and so this would be about a 70 watt amplifier. I'm guessing. We'll find out more about that later. But as the history of these goes, Hartley Peavey was trying to develop a 100 watt solid state amplifier to use for PAs and musical instruments, and in the process of that he ran into an electrical engineer that wrote applications notes at RCA in Harrison, New Jersey, I think, named Jack Sotomayor. And Jack was kind of on top of the power transistor game at the time. He was he was pretty young. He was newer up there, and he'd been writing the applications notes. I think in particular there was an RCA applications note which I believe was AN604, and it had to do with these particular transistors and a pair. And anyways, in my search for information on them, for the schematics and the types of parts in them, I actually had access to a lot of Jack Sotomayor's old notebooks and files that he had left in his office when he retired. So anyways, that was, I think he retired maybe in 2002, so it's been 22 years. But about 20 years later, I was flipping through some of his books, and I found most of the original schematics. And I also found something that was really interesting, which were three letters that went between he and Hartley Peavey concerning this exact power amp design. And I think it was in August or October of 1967, Hartley had finally told Jack that he was able to get 87 watts out of a pair. And I'm assuming that this is that era of amplifier based on these outputs. There was one model before this that only put out about 35 watts, and I've never actually seen one of those that I know of. So anyways, we'll dig into this here and see what we can figure out. And obviously the back's got to come off here. And I took these screws out a long time ago. A good friend of mine who runs the Peavey Cult website on Facebook, named Garrett Cook, gave me this amplifier soon after I met him. And I've always planned to fix it, but haven't gotten around to it. So I had it taken apart when we moved into our new house, and it's still missing the screws. So anyways, we're going to take it apart here. Now, this is a pretty neat trick. When you're taking screws out of a wooden back like this, one thing you can do is, instead of letting the screwdriver ride the screw out, you push in on it, put some force on it the whole time, all the way up to the end, and let it slip a couple times, and just let it hang in the wood. And that makes it a lot easier to, it doesn't always work, and sometimes you got to put a little pressure on it, but that makes it a little easier to keep the screws together, especially if you want to leave them in the original places where they were. Okay, so I'm just going to kind of pop this off here. Alright, and this is pretty cool. Okay, here we have the serial number of the amplifier, 104175. I have no idea when this amp was made. So far I'm assuming 67 or onward because of the power amplifier, but we'll get in there and see the potentiometers and all that. What else do we have going on here? The power transformer's bent. That's pretty typical. Reverb pan's got lots of crust on it. Alright, let's see what's inside. Okay. Wow. This is a very, very clean example of a Peavey hand wiring job from the mid-60s. It's awesome. Okay, so anyways, what you have here is the line cord comes in, and before they had strain reliefs, they would use a knot generally. This is all original as far as I can tell. It looks really stock. Your typical fuse holders you see from the 70s with the big switch and the polarity thing on it, the def cap still there. Here's your power supply section. Now as you can see, or as you may have guessed by now, this amplifier was designed to be put together in modules. And these modules were used in other models like the Vulcan or the Dynabase. Not this particular module, this is the first generation of modules, but this is the preamp. And I'm assuming that this would be the Peavey P1, what they call the P1B preamp, which there's a schematic floating around out there for. And we'll get into that in a little while. So there's one of those, and then there's another one of those with the switching LDR built into it, but you can see this LDR does some sort of turning something on and off. And then here is this all connects to the reverb section, so you can probably deduce that this is the reverb driver, and it goes over here to these jacks which go to the pan. And this is going to be the tremolo board. So this is the tremolo module. So you have preamp, reverb, tremolo, power supply, and this is the power amp that we're probably going to be focusing on. It's hard to say yet, but the power amp here is using, this is what I was actually most curious about. Okay, I knew it had 40411 outputs. And there's actually two preamp schematic. I'm sorry, this is likely the preamp schematic that we're going to need, but I had several power amp schematics. So there was one here which had a couple of 40410s, 40409, two 40411s, and we'll just call those 4411s, 4409s for now, just to make it shorter. A differential input driver there, and a 4408 pre-driver. So I also see a note here that it says to change this resistor to a 250 ohm 5 watt resistor if this happens to be the power amp that we're dealing with. Since this one has two 4411s, this is a candidate. This could be it. Now here's another power amp schematic which has Q8, Q9, Q10, Q11, or 4411. So this has four 4411s. So I have to assume this is an earlier version of the 70 or 80 watt power amp. But now that I'm looking at it, I'm not so sure that the two 4411s don't put out only 35 watts, which means this could be an earlier amplifier than what I'm supposing. But we're going to dig into all that and just take measurements on it and see what we find. I really don't know much about these amps. So this isn't it. This has four output transistors. So it's looking like this is going to be our best candidate. This has four 4411s, and it actually appears to be roughly the same schematic drawn differently. So we're going to say that that's a later version. This is a Peavey 100WG preamp, and this uses DTG 110 outputs, which are germanium. So this is definitely not it. And it has a transformer for the phase inverter, which is pretty cool. But that's not what we have. Obviously, it's not a 200WS. That's a much larger amp, I think. Let's see here. Yeah, it's got two pairs of 4411s and different drivers. So here we have the Vulcan that I'm more familiar with from the 500 series, and it's definitely not that. So we have a preamp schematic for it, and we have a power amp schematic for it, I think. So let's see if this is the power amp schematic for this power amp. So we know we have 4411 outputs. We're looking for a 4409 and a 4410 driver, 2N 4123 bias or current limit diodes, I'm not really sure. and then this is a 4408 driver. So looking in here, I see a 4408 right there, 4409 right there, 4410 right there. These little guys. 41. Okay, 2N 4058 up here. I'm not really sure what a 4058 is, but it may be an alternate number for 2N 4249. We'll look into that later also. And the long and short of it is that this is more than likely our amp. And what I'm not seeing though, okay, here we are. In here you see a string of 3 bias diodes. And what these do is these change as the amplifier heats up to adjust the VBE of these drivers here. So let's see if we have those 3 diodes on the heat sink, because they sense heat. And we do. There's those 3 diodes right there on one of the 2 4411 outputs. Okay, so we have a basic schematic to start doing repairs with. From here we will probably start to look at the power supply next, which I don't have a specific schematic for, but I'm not terribly worried about that because it's a pretty basic looking power supply. Alright, so looking at the construction of this amp, basically going from the power supply to the power amp section of it, you start out with the AC coming in, the line cord, and this is the original line cord and everything. This amp appears to be bone stock. I don't think it's ever really even been taken apart before. There is one exception. When I had it apart last time, I did something that I always do to the Peavey amps this old. I didn't realize how clean it was going to be on the inside when I did this, or I probably wouldn't have, but I went ahead and I replaced the 2 big electrolytics on the outside with some more modern, newer parts. And I used 180 volt, 4000 mic parts to keep the original value that was in there, which were 4000s. And they said Temple. There were Temple capacitors with 4000 microfarads, lower voltage rating than this. But I use these because they're just a Nippon Kimicon or United Kimicon makes extremely good capacitors that last basically forever in a design like this. You know, if you buy a good high quality American sealed part, a lot of times you won't ever have to replace them again. They go bad because they were cheap and they leaked, and the construction methods were different back then. So you put a nice, good, high quality cap in there, it's not a bad thing to do. That's not original. That's the only thing on this amp that appears to have been changed, and that was my doing. So anyway, that's fine, and I don't know if the power supply comes up or any of that, but we have the original line cord here, and it's a 2-prong, and it's made by a company called Belden, who Hartley was in with from the very beginning on cable, and you can see it has a Belden mark right there on the end of the line cord. It's kind of cool. You just don't see stuff like that. And then a built-in core wrapper retainer right there, which was something all the old Peavey amps had. So anyways, it goes through the very long line cord, which modern amps have much shorter line cords. Comes in here through the chassis, and instead of a strain relief, they just tied a knot, you know, to keep it from coming back through. And of course, it would go through this way. Now there is a rubber grommet there, but just not one of the Heiko strain reliefs like you normally see on a modern amp. Then, of course, it goes to the power supply section, and the power supply has a couple of what appear to probably be the output components in the power amp, maybe the emitter resistors and the output choke that's in series with it. What we see here, these parts here. And of course, this is the power amp section. I think we talked about that earlier. I'm coming back today to this, so I really honestly don't remember what we were going to put on here, but we'll go back and check it, and I'll try to make sure I explained everything. And then here you have the preamp section, the other preamp section, which we've discussed the schematics for, the tremolo and the reverb section. Okay, so another thing I noticed on this is that the light is missing. And normally I would assume that it uses the same kind of bayonet light bulb that an old Fender would, but with this being an early solid state amp, I'm not so sure. So we're going to check the voltage going to that before we replace it, because it might be a 120 volt lamp, which would be kind of hard to find. So I guess now we need to plug it in and see what happens. I could take a couple of initial measurements here to just make sure we don't have something like a dead short that's going to cause it to start eating fuses. We don't want to have to use a whole lot of fuses to get this thing going. So solid state amps generally, something will pop on the output. It'll have a lot of current draw if there's something that's going to cause you nuisance problems when you're troubleshooting it. So we'll just look for that kind of stuff first. Now I know that these, I have a data sheet for it here. These 4411 TO3 CAN transistors, they have the two small pins on the underside of the base emitter and the top's the collector. And just a disclaimer, I'm not here to show you how to fix old power amps. I'm basically just here to give you a little bit more of a history lesson on old Peavey power amps. And we're going to try to attempt to fix this, but we may have to come back to it a couple of times for lack of availability of parts. But fortunately I have some old circuit boards stashed in my pile, so I may be able to find something if it's popped. But just for grins, we're going to start out by making sure that we don't have a dead short on the output, which is one of the more common problems. So it would be one of the two 4411s more than likely if there were a dead short. And we know the collector is the CAN, so one of them has the collector going to the rail, the other one has an emitter going to the rail, the negative rail, so it would be negative 40 volts and positive 40 volts. When we flip it on, we'll check for that. So I'm just going to see if I have we'll pop this in here to ground. These rivets are nice, little flute meter probes, because the tip just kind of snaps in. Alright, so this collector is not shorted to ground. This collector is also not shorted to ground. I'm not sure which one is on the emitter side for the negative rail. So let's just flip it over and see. So I think we have two of them. One of them is on a carrier, one of them is not, because of the bias diodes that sense the heat in the bias string to adjust the how much this opens and closes to keep these copacetic. And I have a diode across one of them and a diode across the other. The diode goes from the collector to the emitter in each case, and it's with the cathode on the collector. So if I look at those, and I don't necessarily want to see if it's shorted to ground at that point, because I just want to know if that transistor's got a hard short on it. So I can just go straight across that diode in both cases. Check that out, make sure I got 0 here. Alright, now that diode is going to be, one of them is this little guy, and one of them is this little guy. So this will also give us an idea of the collector emitter junction on the transistor itself, but I would have to use that sensing meter to say for sure. But anyways, it's not a dead short, it's a charging cap. And you'll see this high impedance that changes over time, usually means it's reading. Now what I did there is I just read a good diode, I believe. Or maybe not. I'm reading across the collector emitter junction too, so it's not shorted, that's my point. There's no hard short there, there's no hard shorts here. So we'll be safe to plug it in and flip it on and start checking the power supply. So that's what we're going to do. So next, we want to see what we have going on. I'm going to put the amp up here a little bit. Actually, the wires from these two transistors are coming up through this hole, and I just noticed that the emitter and the emitter leg here and the collector leg here have these two low value resistors in them. So they're going to be these two guys here for sure, because it lists them as a 0.275 watt. So I want to see if either of those are open, because I know resistors like to open a lot of times in these designs. I shudder to call this a quasi-cox. I believe that's what it is. So let's just see before we plug it in. Okay, well, 0.47 and my residual is probably, yeah, 0.2, so same here. And like I said, if you don't know how to work on amplifiers, don't get in here and get shocked and hurt yourself. Those two resistors are fine. This output inductor is probably okay. Yeah, it's the output inductor is just in series with the speaker load here, and it's just a filter there for the output. So we don't have any hard shorts that we can see. Let's check the power supply itself. Coming off of these rectifier diodes, we could go to ground and just see if we have a problem on either rail. So the AC is coming in here and here, so the DC is going to be coming off here. Good, nothing, and then here. So no shorts to ground that I can find that I'm worried about. It's going to cause me to want to put it on a limit box with a light bulb in it, for instance. You can put a light bulb in series with an electrical outlet to kind of, it'll soak the current if there's a hard short, you know, in an amp like this. And it's really safe to do that kind of thing. But I know enough about this one to not get worried about that. So we're going to take our original belt and line cord, make sure we're in the off position. Oh, we do have a good fuse, and it does look like it's been replaced. The fuse is also not original. That's another clue. Now that could have been me before I replaced the caps last time, but I'm pretty sure I didn't take any measurements on it. So we also have a little fray in that line cord right there. I'd like to keep it original, so I may just try to put new insulation on it. But anyway, let's plug it in. Good old 2-prong outlet. Now the depth cap's in there, so it's possible that you may be able to put 120 volts on the chassis. I don't think we're going to have to worry about that here because we're not connecting it to any external equipment. So let's see if we have another common problem that you would have with a power amp that I would check for DC on the output. I don't hear anything coming out of the speaker, but there is minus 26 volts on the output. So right off the bat, I know that this bottom 4411 is conducting, or that diode or something, in some kind of way that's putting a negative voltage out here, or one of these earlier parts in the power amp is throwing the bias off. And so we have a power amp problem, no question about that. But it's not the kind that draws a buttload of current that you have to flip the amp off for to check it, apparently. And if I look in here in the power amp, I see a couple of parts that are bubbly, but they're not bubbling, they've been hot. And one of them, there was one where it said to change it to a 5-watt resistor, and it's a 270 ohm 1-watt part. And that is a 270 ohm 1-watt part, and it is really hot. And so I'm assuming that that needs to be replaced with a 250 ohm 1-watt, which we're going to do. Let me just see what kind of voltage I have on both sides of that to kind of confirm. So minus 26, minus 26. So that resistor has been hot, but it's not hot as a result of what's wrong with the amp now, because it has the same voltage on both sides of it. That means that potentially this transistor here is bad, or this one, and it's throwing the bias off on this. And one way or another, we have the same thing on both sides of it, and that's not right. So the power amp has a problem. Now, just before we start digging into it too much further, let's see if we're going to be able to pass a signal through the preamp or see anything adverse on the power amp while we're running the signal into it. And there again, I don't mind doing see, I just had two hands on it, but I know that's ground, so I'm good. Alright, so I'm going to turn that down, that's the volume, and I'm going to come in here, flip my scope up to my signal generator, and I see that I do have a little bit of little bit of signal there. Now let's see if the signal is being loaded. I'm going to check the signal before it goes in. It's that big, and after it goes in, it was about the same size, so the input of this is good. Alright, now I'll head on to the input. This is a cool circuit. It's got 3391s, which is a really high gain transistor, going to a PNP follower, basically, which drives a volume control, which goes to another gain stage, which has a cap switched in for something. Now this is the tremolo driver. This LDR would go to the tremolo, and it would modulate the input of this stage, and then you get a bum, 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 bum. So that's probably what that is, and that explains why this channel has an LDR and this one don't, because let me flip this off for a minute. Because this is the reverb input and this is the clear input. That means that the reverb input is probably the only one that has reverb and tremolo. This is reverb and tremolo over here. So let's flip it back off. Okay, we had a signal coming in right there. Looks good, and it's going to the input, which would be 0.05 and this. So I'm going to say this one and this one, and that is a 3391. So I got an input coming in here, and I know that this 1K and that collector would probably be the output on the next stage. That's before the volume control. So next we'll just head on over to the volume control, and I'll just jump right on the wiper of it and see if anything's coming out when I turn it up. And it is. Okay, so I'll just leave that up, and then I'll go to some point past the EQ. This is the EQ here, which is going to be this low and high control, bass and treble control. And they're fed into a gain stage that's a single transistor. It's actually a Baxendale filter with the resistive and capacitive elements in the feedback loop of this transistor. So this is going to be the output of that preamp section. So let's see if we got anything over on the wire that goes from the preamp to the power amp, which I would assume is either the power supply or the output. That's there's one there. Here's a wire coming in here. I already know, I think I know that this is DC. And this will verify that the DC is right in there. If we look, you got 25 volts coming in, 1K, which that's a 1K, and that's 23, so that's probably pretty close. And then on the other side, it bumps down to what it says is 14, so this probably be 15 or 16 on the other side. We got 16, so that's good. Alright, so our supplies look good. Now that we know that's the supply pin on the preamp, let me check the second one over here. Looking good. 16, just like that side, so that's good. The reverb section would have to have some sort of a power supply that probably comes from some sort of a wire, which would probably be the plus 40 volt supply. So the reverb runs off of the plus 40 volt supply, and a resistor knocks it down to about 33 to power the reverb circuit. And then I'm guessing the tremolo is getting its supply through this big power resistor. So let's see, 13 on that side, 40 on that side. So the tremolo runs off of 40 volts too. I don't have a schematic for the tremolo or the reverb. I'll try to round up a tremolo schematic, but the reverb schematic, I think we could probably just make a determination on whether it's working or not by getting the signal to the drive, and then, you know, if the voltage is on the return side or okay, we'll know when we hook the fan up. So anyway, this preamp coming to the output of it here. Let's see, did we decide if that was the output? I'm trying to use a voltage probe to measure the scope. Okay, so anyway, here, back to the scope. Oh yeah, okay, so to the output of it, it goes to the power amp. The volume control is doing its thing. It's clipping pretty hard. I probably have quite a bit of voltage going into it, but let's do that. Kind of, yeah, nice little range there. It's probably got some pretty gnarly clipping. But that Baxendale EQ is a cut and boost EQ, and it does a lot. So here's the low control at 100 hertz. I'm sorry, at 100 hertz. So it almost kills the signal and then boosts it on into clipping when you turn it up and down. Here's the treble control. At 100 hertz, you don't see it do a lot, but at 1000 hertz, the treble control is kicking, and it can go into like total ridiculous clipping territory with a pretty minimum signal, and got some good pushback, some good you know, for whatever that is. I don't know. May have a bad cap in the power supply. Probably not though. It's probably okay. Those low-level caps are usually pretty good to go. So anyway, the EQ is doing what it appears to need to be doing, and the volume control is working. So I'm going to say that preamp stage is probably okay, at least before we listen to it. Now let's go to the second preamp stage, which should be identical. I'm going to pop my signal in there. This is the reverb input. Now let's set those at half and the volume all the way down. Alright, coming in, not very big. So it's possible that I just adjusted it. I did. Okay, I just adjusted that. So right here. Much smaller signal coming in now that I know I have a ridiculous active EQ going. It'll be kind of hard to trigger that. That's okay. Now come into the reverb. And we're still on. There's the input that I had right there. Going to the input of the board, it's still there. Coming to the output of the first stage, it's much larger. Let me try to trigger that. I'm going to have another scope up here before I do another video. This one's Tektronix 465. It's probably at least 50 or 60 years old. It needs a calibration and all that, but I need to modernize a little on that. But anyways, it's coming out of the first stage. After the first stage, we go to the volume control. So let's go to the top of the volume control. Nothing. Before it gets to the volume control, it comes out. Okay, well we were here, and we saw the signal looking like it was kicking butt. We came here and we saw that it was not kicking butt. So this is the only thing in between those two parts. 2 microfarad 25 volt cap, and the wire going to the top of the potentiometer says it's that guy right there. So let's see if there's something on either side that's coming into it, but it ain't coming out of it. This capacitor is bad, so I have to find that. Now let's talk about that for a minute. This amp is stock. It's old enough to be considered historical because there's not very many of them. It'd be really cool if I wouldn't have to replace that with a different type of part. These caps are from a company called Ritchie Electric. That was kind of a small manufacturer back then, and I'm sure it was the lowest cost supplier that Hartley could find to buy those particular types of caps from, or possibly they gave him some kind of deal, who knows. But it has those, and those are odd. That you don't really find them unless you have scrap boards, which I happen to have a few of them around. And some of the other components on here, like these orange drop caps, they'd be pretty easy to find. But I'm going to try to keep them period correct. I'm going to try to find other parts from whenever this amp was built. And we hadn't talked about that yet. So we have a bad preamp with a bad capacitor for sure. We'll go into that a little bit more, but we need to figure out when this amp was made. And these less expensive parts, a lot of times you'll find yourself at a loss for finding date codes on them. Now I know there would be some on the pots on the other side there. So let's just unplug it for a second. And I can't really see them without taking the pots out. And I'm not really sure that they even have EIA codes on them because I'm not really familiar with that type of pot. It's a, it's got like a little ring on the back. It doesn't look like a CTS at all. Maybe some regional manufacturer from that time period that didn't have an EIA code. But let's see, where might we be able to find a date code? Hey, these resistors here. These little guys do have date codes on them. And the date code is very hard to see, but it's 6830. So that resistor was made in the 30th week. And let's see if we can get a signal going in to the power amp here. Nice. Okay. It comes over there. Now the power amp, we determined that it was this Peavey power amp P2A that only had a pair of 4411 transistors in it. And we haven't determined whether that's a 30 or 35 or 70 watt power amp yet, but I'm thinking it's going to be higher than 35. Now, I know that the signal's getting to here. There's a 2 mic cap, 1K resistor with a 18K to ground. So at that junction there should be a signal. 2 mic cap, 1K resistor, 18K to ground. So I'm going to get on top of that 18K and my signal's there. So be coming out of the cathode of that, there should be a signal coming out of there. And that's a 680 ohm resistor. And I know that these boards are laid out like, I don't see anything on that. Okay, so let's check the DC around that there. So the schematic's telling me that I should have, I know this is minus 40, there's a 100 ohm resistor there, this is going to be a little lower than that. That 680 would have to be drawing some current for it to be different on this side. So it's probably not drawing much current when it's idle. So I'm looking for 39 volts there, minus 39 volts there. I got minus 37, so that's probably right. And if I go to the collector side of this differential pair here, I notice there's an 18K coming into it. There's an 18K coming out. So there's probably only a couple of 18Ks in that area. One of them is going to be coming back from the output, and I'd expect that one to be sitting at minus 26 volts on one side, potentially on both sides, because, well, that would turn this transistor on, and then it would also be up here on the collector, or something would be on the collector. So let's see what we got on the, there's an 18K and an 18K. So I'm going to say that the first one's probably going to both, it's closer to both. The top of it's going to the, approximately to the rail, which is almost 40 volts, and then the bottom of it is at minus 2 volts. So the collector of these two transistors is sitting at minus 2 instead of 0.6. The collector of this one looks like it's sitting about where it's supposed to, and this one too. They're both 39, so I'm going to say the center is probably the collector. They're both sitting there doing their thing. So one of these may be bad. We'll go in there and poke around with that some more soon, but I'm guessing that this 4408 here is not right. So I should see minus 6.9 on the collector of that. So a 4408, that's the 4408. These are odd little packages that they come in. That little metal can transistors from the old days. I think the collector is always on the case. It is. The collector's on the case, so we can just poke on top of it and see if it's getting its collector voltage. And it should be, it says here minus 6.9 volts on the 4408. Another thing you can't take stock in is whether or not they wrote these voltages down right. I don't know who designed this thing. It wasn't Sotomayor. It was somebody whose initials are FGM, and Hartley approved it. And this was before Sotomayor, so there wasn't as much engineering going on at the time. But that's sitting at minus 37 volts. So kind of looks like it might be shorted instead of sitting at minus 6.9. So the base could be blown, or it could just be shorted right across there. I'm going to say that I probably need to shotgun that sucker. Of course, I'll pull it out and we'll check it before we do anything like that. But I'm going to have to find an original board with good parts on it to fix this one, it looks like. So we know that the power amps, for lack of a better word, fried. We're going to have to do some more troubleshooting on that. We could probably go in here and kind of poke around on the reverb and see if we see what we got. 40 rail coming in, 33 power and everything. So if it's got a couple of MPS small 65, 66 power transistors, not familiar with that one. 40 volts on it, 11 sitting in there, 0, so that might be ground, 11. And then there's a TIA871. I just don't know what these are. I have to do a little more research on the reverb to get it traced out. But the tremolo, we could probably determine whether the oscillator is working. There's a rate and a depth control. Tremolo circuits usually aren't very complicated, and they'll usually be like an RC oscillator or a bridge oscillator of some sort. And I see that I have a TIS94 transistor here. Let me turn this off for a second. And don't want to break that lead. A totally unmarked JFET of some sort, I'm going to say, because that package was generally a junction FET around the time Hartley was building these amplifiers. There's a JFET in the transistor, in the tremolo circuit that I'm familiar with. I'm going to have to dig that up. Anyways, to check if the oscillator's any good, you can just get on this pot and look for a signal, an oscillator signal of some sort, or just go back to the circuit that it goes to. Okay, I'm using my voltmeter again, sorry about that. We need a scope probe. Hey, look at that. I get right on the wire there. See it, so that's good. Let me get in here where that wire goes. That cap looks good. We're going to get on that 2-mic cap, see if we can take a closer look at the... Yeah, so anyway, we have our rate controls working on the tremolo, I think. The oscillator works anyway. So we got, let's just go to channel 2 here. Okay, that's with the rate all the way down, so it'll be like that fast with the rate all the way down. As I turn the rate up, it definitely speeds up and the signal gets a little larger. So that's our fast speed, and that's our slow speed. So we probably have tremolo, if I had to guess, and it probably modulates that LDR. So let's take a look at that LDR. Come over here. There's the modulation on the LDR. Okay, so the tremolo is probably working, but this preamp don't work, so it don't matter. So at least now we know what we got. We have to at least replace one capacitor here in the preamp. I need to try to find a 4408 transistor. I don't know about these 4410 and 4409 transistors. I didn't measure it short on the main transistors, so I'm really just going to have to do diagnostics on all the transistors on this board just to see what I'm going to need to replace and what I'm not. And like I said, I do want to use period correct original parts, so I'm going to have to go dig up some boards out of my stash. I have some boards because when plant 2, the guitar plant at Peavey, was being more or less liquidated and emptied out, me and my boss Hartley would go over there and we would just go digging through things in the old trash that they had up in the area called the dungeon, and they would basically just throw stuff up there that they didn't have any use for anymore because they never threw anything away. And we went up there and there was so much stuff. Well, anyways, there was one 55-gallon drum full of old circuit boards, and it was these first generation Peavey circuit boards, the preamp modules, the power amp modules, tremolo modules potentially, and I have a lot of those. I don't know what's wrong with them, but they probably have tons of good parts on them. So we're going to go dig up some of that and look around and see what we can find. And we'll be back. Okay, so we're back, and I've found some of the parts that we need to get this amp going. We found some old circuit boards from the old days out of that 55-gallon drum that I salvaged from the old guitar plant some years ago. And we have some transistor options here. I found a 250 ohm 5 watt resistor to replace that one that was denoted on the schematic here to change, so we're going to update that. Pilot light, I'll talk about that in just a minute, but these old power amps are pretty interesting here. I have a few different examples. I think the earliest is going to be this one, and this was this hand soldered prototype, so I guess they built this and something didn't work about it, and so they threw it in that scrap bin, but it probably has some good transistors on it. Here's a pair of 4409 transistors, which this has one of on it. This amp is slightly earlier than this, but this was a 100 WG, and this was used in the 200 series of amplifiers. And I think it was the first one to put out 100 watts. So I thought that was pretty interesting. And then we have this this later amp, which has three 4409s in some kind of configuration, and then a 4410, and these went out to drive TO3 transistors, similar to this. Either some 4411s or some, what's the number, 3055s, I think, the next generation TO3s that came out after those. And on one of these boards, this is a really early board here, it has a 4409, and what's interesting about this one is that the board never was actually soldered. It was just scrapped before it could be built up, and this came off of the base from the really early days, probably a 500 series base, and this was the driver for the 200 watt power amp, I think. But anyways, what I found was a Ritchie 2 microfarad 25 volt capacitor, just like the one that we have that's blind right here. So I'll pull that off of that board, and we'll have a stock part to stick in there. I never fully determined what the deal was with this. I believe that the 4408 was shorted, so I'm going to go back and re-verify that. So we have to probably replace that, and then we have to swap out that resistor right here that we talked about. So without further ado, let's take a look at the power amp again. And we have this 4408 that I'm supposing is bad. And if you look at the circuit that it's in, you say, well, this is minus 40 volts and this is plus 40 volts, and then this transistor is in this circuit here, carrying a good bit of weight when it's in certain modes here. So anyways, what we would expect to see if it were bad would be some kind of short on it, more than likely. But it's a 90 volt transistor. It's probably made from the same die as the 4409 and 4410, but if you look at it here, it has a much less substantial heat sink. So I suppose in a Class A configuration like this, which this would be a Class A driver to these push-pull transistors, it would be drawing current all the time and would probably be more likely to fail. So we're going to take a look at that, and let's see here. So we're going to have to pull him off. We'll have to pull this capacitor out. We'll have to pull that resistor out. We'll replace those. And another thing of note here is this amp's from the mid to late 60s, so one thing that's interesting on it is that if you look at these flathead screws, which they're flathead screws, which is just kind of odd nowadays, but if you look, there's some black adhesive on there on each one of them, which indicates that these screws have never been removed, which is really interesting. So I'll be the first person to take these boards out and do work on it. All right, so we're going to take this 2 microfarad capacitor off here, and I measured it to verify that it was good. And we're going to use this old school solder sucker. Now this is on this old, really heavy copper clad board, and they'd buy the copper clad board and then mask it with something that they washed off later and then etch it with that nitric acid. And they Hartley made his own circuit boards back then. Okay, so we got that loose, and we're going to kind of very gingerly and carefully remove it. Okay, and there's our 100WG power board. What was interesting about the 100WG is that this drove a pair of germanium WTG Delco DTG 110 transistors, I think they were called. But it was a really odd germanium output circuit, and it had a phase inverter driving the outputs, which was pretty common for Delco. I think that whoever designed their transistors was fine with transformer phase inverters. Okay, so we have this here, and it looks like we're going to be able to save it. So just kind of bend the lead straight. Just kind of get that ready to go back in. Alright, and we'll just, we got a good cap there. Now we're gonna break the seal on the black glue on this board right here. Let's see if we can hear it. Do you hear that glue break? Awesome. That's like not even gonna go there, but that's pretty interesting. Okay, so I'm gonna drop these in here next to the other screws that we've taken out. Here comes another one. Ready? Not as bad as the first one. Let's see. Number 3. Kafoo. Put that one here, and then we got number 4. Alright. Our board is free. The seals have been broken. It was this one coming into the pot, if I remember correctly. And that guy does not have much slack in the wires that are connected to it, so probably going to go ahead and take this other board here loose, since it's going to need some stuff replaced anyway. Bam! Now the power amp was pretty solid on the glue. I'm not going to worry about putting the screws back in the original locations, because I really just want to hear the amp at this point. Now on a tube amp, you would want to make sure everything is discharged, but solid state stuff is not quite as big a deal. You just make sure you're not plugged in, and that you don't have big caps around to scare you. Now there's a ground tab on this screw that goes to a capacitor right here. So I got to make sure I keep all that intact. Now, there we go, a little better. And I can kind of get these guys out of the way. It's not really going to help. Okay, so anyways, the first thing we're going to have to do is replace that 270, what it was, 270 ohm 1 watt with a 250 ohm 5 watt. And it has been getting hot, so we're definitely going to do that. Let's go ahead and snatch that resistor out of there. Now here, check this out. Now here's the other board, and this is a Peavey P2 power board. If you can see that, and this has the clear film on it, to keep the conformal coating, and all the original parts there. The tabs for the power transistors aren't soldered, which is interesting, but it's a nice clean wave soldered board here, kind of like the ones you see there, but that's what it would look like if it were brand new. Okay, so I don't really want to breach any of the wires in this case, so I'm going to just kind of prop it up like that and go after it. Okay. Now, in all likelihood, I'm really going to have to probably take the board out and do it right for the transistor, but let's see. Man. very careful not to damage the board. Okay, and there'll be that outer lead right there. Okay, pretty good. I'm just going to kind of break that skin of solder away on both sides. And then come over and yank it out. Now that spot's really small, so I'm going to just kind of stand it up. Bend the other lead down. No, not either. Maybe I'm just going to stand it up about like that. See if it'll go any other way. Absolutely. It looks a little weird, but I'm sure it'll be functional. And we're going to make it real clean. I've been throwing around some ideas for the next video, and I'm thinking that I'm going to go with a 400 or 500 series Vulcan, possibly a RestoMod, where I put a ICEpower module in place, like a 1200 or 700 watt ICEpower module in place of the existing power amp. And leave your comments in the notes below there and let me know what you think about that. Okay, so now I got to yank that little dade right there out, and it looks like I got a really good shot at just kind of popping all of those. Well, no, let me get the solder off. I don't want to take any chances. Try to keep everything pretty clean. Now I'm assuming the transistor is bad because I measured a short from the collector to emitter. But these old guys here, a lot of times, if you leave the heat on them too long, they'll pop. So when I'm putting these new old 3440s in, I'm going to be really careful not to leave the heat on them for very long, because I don't want to take a chance of burning it up. You have to really be cognizant of that. Okay, now I lifted a piece of copper on this one. That's not what you want. So that just goes to show you that they don't have very heavy copper on them. And even though it is heavy, the adhesive holding the copper to the circuit board is old, and who knows how strong it was when it was originally made. So we're just going to have to be super careful with it. There we go. Okay, I got it. Now, I do know that it was the 123 was the emitter base collector, so it was the emitter base, emitter base and collector, because I see that that's welded right there, so they don't have a very good diagram for it. So I have to figure out how to get that heat sink off, and it looks like it's probably a compression fit of some sort, and we'll figure that out in a second. Let me just verify that the collector to the emitter was shorted. So, here's the collector and here's the emitter. It's not shorted anymore. Is right. You see, when you're in a hurry, working on boomer era solid state power amps can really suck. Deductive reasoning and time-honored measurement practices and traditions are prudent. And whilst you may find yourself wanting to swap every freaking part on the board to save time, remember that you could have hired a professional. With that said, let's go back and see how far I was able to progress in keeping this baby as clean and stock as possible, shall we? All right, and we're back at the bench after a lot of thought and iterative swapping of transistors and a little bit of trying to redesign this old P2A power amp circuit. I have chosen to cut bait and go with the ICEpower module. This is an ICEpower AX. It's the 50 ASX2. It's 50 watts per channel, but it'll do up to 170 watts if you bridge it. And I'm going to try to come up with some kind of configuration to put this in. I need to add some spacers here. Interestingly enough, 2 of the Z-clip spacers I was able to just bend and rotate, and they line straight up. But they're not; those aren't the ground points for the board. So for those, I'm going to actually use an actual metal spacer that goes in there that's the right height, that sits in there, and the Sharpie's just keeping it about the right height for now. So these are the inputs from the different sections. I'll build a small mixer stage of some sort, probably similar to this phase inverter circuit, if not something kind of like that, to mix it in to go into the ICEpower module. Now the trick's going to be getting the gain of this system to match the gain of this system between the preamp and the power amp. And to do that, I'll probably have some kind of little adapter circuit hanging off to the side somewhere with this phase inverter circuit to drive the differential inputs of this, or possibly something else. I don't know. I haven't really decided what I'm going to do, except for that I am going to use an ICEpower module, and I'm going to make this thing useful rather than try to muck with something that I have determined is inherently unreliable. Let's go back to the linear power amp that I was messing with for a little while. I'm going to keep this for reference. This is the Peavey P2 power amp, like we were talking about before, and this is the original schematic for it. Now, we were coming in here, we were going to this to split the phase, and then going to this Class A driver to hit the bottom half, and then the other phase hit the top half, and there was some current limiting involved. What I realized when I started getting in here replacing semiconductors is that this bias string was kind of indeterminate up against this 15 ohm resistor, depending on which parts you had in the system at a given time. It was inconsistent. I could get it to work, and then when I would go to do a burn-in, I just couldn't keep it reliable to the extent that I would like to. When I do a burn-in, I like for the amp to be able to do 1/3 power into its rated load, into its minimum rated load for at least 10 or 20 minutes, especially for a guitar amplifier. And this was not capable of that before something would go awry, come out of thermal happiness, and blow. So I've deduced that the reason you don't see very many of these old power amps working, or any of these old amplifiers working, is because the power amps are finicky. They're pretty unstable. Later they found out that if you select components, you can get a lot more consistency from unit to unit, that they're a lot easier to build. But anyways, in the case of this old standard 4411, 4409, 4408 circuit that we got out of the RCA book, it just has inherent problems when you go to do a burn-in, and you'd have to have your transistors selected just so for certain BBEs. And I popped about 2 or 3 4410s before I realized that I didn't want to try to redesign this. I tried to lower the current, the bias string, and all the obvious stuff that you would do, and I couldn't get a reliable solution that I was happy with. So I'm going to go with the Class D module, and we're going to be able to see what this preamp and tremolo and reverb sound like in their true form. Their intention was to have a clean power amp in the first place, so we're just going to go back to that. And we'll call this a Musician ICEpower RestoMod. And if we can't get this to work without having a fan integrated or something like that, I'll probably go to a different module. But this is what I have laying around, and a good friend of mine at ICEpower, Paul Meister, sent me a few of these several years ago that I ended up not having a use for. So I'm going to pop this in there and see if I can get it running. And some more background on this power amp. I do happen to work at Peavey, and I work in the engineering department. And I did take Jack Sonemeyer and James Brown's old job through attrition over the years. And going through some of Jack Sonemeyer's old notebooks, I found this letter dated August 11th, 1967. And it's from guy named Jim Owens that worked at RCA. He was a sales engineer, and he says he's telling Jack Sotomayer's boss Riley, "We have a customer down here who manufactures transistorized amplifiers for electronic guitars. He's buying transistors from one of our distributors and is a growing concern." So this is when Peavey was just starting to grow, and Hartley was starting to get in touch with RCA directly to try to find out why their application notes didn't seem to work. ATC 408A. This is the application note that you'd hear him refer to in interviews sometimes. And right here, this is interesting, because this I recognize this as Jack's handwriting, but this is where Jack wrote down Hartley's address and all that for the first time, probably, after he got this note from his boss. Here, by October, Hartley sent Sotomayor another note, and he thanking him for the help that had given him on the design of this power amplifier stage, or the predecessor to it, which was slightly less power and used slightly different devices. And he says, in our phone conversations yesterday, there were several questions I failed to bring to your attention. What would it take to get the sensitivity up by a factor of 5? We're going to construct our prototype as soon as we can gather all the parts. If you've not already done so, please check on the possibility of sending us samples of the 4409s and 4410s with integral heat sinks. What is the availability of these units? And that letter is the impetus for where he sourced that family of transistors. And these are the ones with the integral heat sinks that he's talking about. And you know, like I say, you can see through the progression of this that they're learning, you know. So here we go a couple of weeks later in October. Dear Mr. Sotomayor, this is from Hartley to Jack. We've got the new amp working, but we run into several problems in getting the power out with the protection circuit cutting in too soon. As soon as we got the 4406s, we got the amp working, but found that the protection circuit acted too soon to work on a 4-ohm load as presently built. The other trouble is that we've been unable to get more than about 87 watts into a 4-ohm load because the 4409 does not have enough gain to match the 4410. And I could see problems in the design based on some of the repairs I was doing when I read this, and some of the things that may be contributing to that, like the VBE difference between the PNP and NPN devices and their compensation and all. And this just looks like less and less of a great circuit now that I can fast forward 60 years and look at the technology. Anyways, he goes on to say that his engineer thinks that he may be able to use different values for R3, R4, and R5 to get more drive for the 4409. What do you think? We would like to use parallel 3055s rather than the 4411 because we buy these in large quantities and want to avoid stocking so many power transistors. Would this be wise other than being more complicated than using a single 4411? To compete effectively with the competition, I think we should have at least 100 watts. And this proving to have, I mean, to have at least 100 watts, at that point, when Hartley was able to accomplish that, he was able to take over the PA market. And all the Shure Vocal Masters and box PA systems just kind of fell to the wayside as soon as he was able to get some gain and some power. And this is how he got it, working directly with the engineers at RCA. 3 or 4 years later, Hartley actually hired Jack Sotomayor, and he moved down here to Meridian and lived here and worked here until he retired in 2002, I think. And I was fortunate enough to work with him for about 3 or 4 years before he retired, and he taught me a lot. Anyways, that was just some interesting history. Then here's the original preamp schematics. There's a tremolo circuit it's not the tremolo circuit in here. It's a slightly more elaborate one they were working on to get rid of the click. And then here's the fuzz circuit that we will go into at some point in the future when we look at a Vulcan. But for the musician, we're gonna cut bait on that 4411 power amp design, and we're gonna go with an ICEpower module. So next thing I have to do is figure out some sort of interface to get the gain, determine where I'm going to take the 2 speaker outs, and whether I'm going to keep them separate or tied together. So there's a lot of decisions to make, a little bit of wiring to do, so I'm going to get started on that, and we'll be back soon. Alright, and now we're back. We we have the ICEpower. Unplug this for a second. Have the ICEpower ASX52 module in there. I'm sorry, 50 ASX2. We went with this one because it puts out this in this configuration. It puts out about 65 watts into 4 ohms, and it derates down to about 25 into 16. So there's a stereo version of it, and there's also a bridge-tied load version. The bridge-tied load version, which is the BTL version, puts out about 170 watts into 4 ohms, which is it's a lot of power, and that's cool. But I didn't want to have to add a fan to this amp, and to keep it more authentic, I went with the 64 watt power rating at 4, which actually kind of breaks up and derates extremely similarly to the original solid state power amp. And also, I kept the original power amp here. I haven't totally given up on it. I just can't find good devices for it, and I want to get them matched and everything. So what I've done is I've taken the old 70 some odd watt power amp out of it. I left the output devices on the back so that it looked authentic and all. And I took the ICEpower module, and I basically took 2 of the existing Z-clip standoffs and just rotated them slightly, and they lined up perfectly with the 50 ASX2 module. And the other 2, I bent slightly and turned the other direction, and I was able to use the original screws on this little adapter board that I built to adjust the gain between the preamp and the power amp. And we'll talk about that some more in a minute. So if I want to go back and fix the original, we can look at the bottom now too, the original Peavey P2 power amp. I have the option to do that without drilling any holes or modifying anything at all about the chassis. And since it's not the bridge-tied load version, the outputs are grounded, and I'm only using one of the outputs. And the reason for that is because the power level comes out to almost exactly what it would have in the original, and you don't need a fan if you only run half of the amp. If you run the entire amp or run it in stereo, which I thought about trying, you'd have to have a fan to keep it cool when it was running at full power. And I want to be able to play it, and I don't want to have a noisy fan or have to drill any holes in the chassis, because I'd originally wanted to keep it original. So anyways, we took the wire set that came with the amp and put the AC in and the speaker connection. Now, an original feature of the Musician was that it had an internal speaker jack, and the second one labeled as an external speaker jack. And when I looked at it a little closer, I noticed that it was really bizarre in that these jacks are connected in series, and that was a feature for Peavey, to not have to worry about buying speaker, or having to worry about warranty repairs, because when you put these the load in series, it reduces the power output of the amp. It makes it run a lot cooler, etc., etc. So it's just kind of funny that they did that to protect the amplifiers, because they were so concerned with them being overloaded, etc. So basically, I left the series connection in there so that it would have the same power derating if you had old cabs and everything. It would work exactly like the old one did. That was just something that kind of fell out of it. So I opted to go with a lower powered amp and only use half of it to avoid a fan, to keep it about the original power level, and to have it to where it was a real similar sound. Now, since I don't know the exact gain that was being used to drive this power amp, well, actually I can kind of calculate it, and it's roughly to where it would, if you were playing through it, to where it would clip when the volume were about halfway up and everything, with the Jazz Master, since that's what Hartley designed these with at the time. He had a Jazz Master that he built as an exact copy of a Fender that had pickups that he made that were. Anyways, he used that guitar and a Jaguar to test everything that they built back then. So we're going to put this old power amp back up. And now we're going to talk about this adapter board right here that I made to interface the original Peavey preamp with the ICEpower power amp module. What I've done here is just ignore this. I used a 7812 12-volt regulator because there's an auxiliary supply here on the ICEpower module that puts out about, I don't know, plus or minus 25 to 27 volts. And they have a spec on there that says if you run it through at least a 10 ohm resistor, you can add some capacitance and some I used a 78 L12 regulators here to put 12 volts onto a 5532 op amp. And I hooked it up this way because I didn't know if I were going to use if I were going to use the bridge tied load version, I would have to have the actual regular inverted signal going to channel 1, and then you'd have to invert it one more time to send it to the opposite side so that you'd have opposite polarity signals driving the power amp. And then you don't ground the bridge tied load power amp. In this case, I was able to just leave the second half disconnected because it's a single-ended power amp and you only have to drive the one phase, and I'm only using one channel. So basically what I'm going to show you next is how I would go about setting the gain to get it to where it worked about like the original did. And I had another one to refer to see, and it clips when it's set at about halfway, with everything halfway with a with a medium humbucker, a PAF level humbucker. So basically, since this is a real simple inverting stage and this cap's extremely small, I'm just going to dial that resistor down a little bit to kind of harness it and to keep it where you can hear what the original preamp circuitry sounded like. Because see, we've done a couple of repairs here, fixed some caps that were shorted, and the preamps are 100% stock. So if you wanted to know what a Peavey Musician sounded like here, I'm not going to modify it any further than that because I'm not using it for it to sound good. I'm keeping it as kind of a historical reference. So the reverb circuit works. It has I don't have a schematic for it, but I looked at it, and it has a PNP and NPN push-pull pair driving the reverb pin, a small power amp circuit like a lot of old reverbs do. And it's funny because it's real basic, real rudimentary, because the rail goes straight to the transistor and then the output goes straight to a coupling cap. There's no like emitter or collector resistors on the top or bottom. It's just mainline, crossover, distortion, funky reverb coming out, and just really lush, gooey, distorted, just nasty sounding reverb as a result. And they made improvements on the 200 and 300 series to that circuit. And then the tremolo is extremely weak, but I think it's correct. I'm gonna play with a couple of resistor values in it based on some notes I found that Jack Sotomayor had left, but I think it's doing about what it's going to do based on the circuit. It's real basic, real simple. So anyways, these two channels, channel 1 and channel 2 with the LDR for the vibrato and the reverb, mix through resistors that they had on these modules that sum them into a given input. In this case, it's a 5532 op amp because I wanted to keep it all real clean. And the reverb pan itself is really cool. It's an old Gibbs reverb pan from before Accutronics, when they were kind of like a sublet of Hammond, at the time. So it's a really cool, really nice reverb pan. It's a really good pan. It's a little ugly. So anyway, we're going to put all this back together and check it out. But before we do that, we're going to fire it up and we're going to listen to the gain adjustment here. And so I'll just leave it the way it was when it was stock. Now, we're going to be able to look at the output of the amplifier on the oscilloscope here, and I also have it because of the series connection. I could put I think I put a 1 ohm load here, and then I have my 16 going to the 16 ohm speaker cabinet, and I'm doing that to basically keep the volume down low enough for the camera to deal with it in this little room. Oh, and one other thing before I turn this back on, the pilot light. It's not a conventional 6.3 volt pilot light like you'd find in a Fender, because this isn't a tube amp, so it doesn't have a 6.3 volt heater winding. What it used was an NE51 neon light, and it's a 120 volt bulb. So we'll pop that guy in there. And if you're ever working on an old solid state amp, keep that in mind, because they may have used a 120 volt light or 240 or whatever instead of a 6 volt light. So see if that comes on. yeah, it's a nice, looks different than a Fender. It's a really cool looking light. All right, so anyways, let's see, we'll just run through what it does real quick. This is the clear channel. Let's see, with the real hot resistor value that I put in there. So let's just look at the waveform. With no EQ though, so this is a cut and boost EQ, so to be fair you have to start with the EQ knob from 5. Very gnarly. We're clipping that power amp and possibly the stage before the that's a that's happening before the power amp, and we're very interested in that clipping because that's part of the way this amp sounds, and what I was talking about on the reverb here. The reverb adds a little bit of gain to it, and as you can hear there's some little artifactual gnarliness to it. Actually, I didn't have the reverb on because I'm on the clear channel, but we'll get to that in just a second. So, as far as adjusting the gain, I know these two channels are similar. I know this one's a little hotter though, so we're going to go into that one. So we want that to just barely hit the power amp when we're at halfway with a humbucker. So on this guitar, I can turn the humbucker on here. Let's see. Still pretty high. Now we're getting into the preamp distortion a little. We don't want to mask that. That's a pretty good compromise. Okay, that's on 2, 3. Now let's see if the EQ blows it away because it's active. That's a thing that happens when you turn the lows on. When you go to a single coil, it's pretty cool. Okay, so that's some stuff I'll run into later. Now the treble. It does the AM radio shrill thing. Pretty cool when it's wide open. But as you can see here with it maxed on 5. Some pretty good distortion, and if we back off on the volume, so we'll go back to 5 on everything, max out the volume, go back to humbucker, back the volume down a tad. By the time we get to 7, we're getting out of power amp clipping territory, so I'm going to let it go just a tad hotter. was about what we'd expect. So we will turn it off, unplug it, get all this stuff out. I had a 110K resistor here on my diddle box when I was done, so I'm just going to add a 110K in parallel with the 220K that's there. And I'm not going to fool with the cap because it's 1 nanofarad, so it's going to take the high end out to 80K or something, but I'm not picking up any radio stations, so I'm not really worried about that. And also, I found out some other cool things about it, but it's I think the third version of the power amp that they did, it was actually there was a 35 watt, a 70 watt, and later they came up with the next one that was the 100 and some odd watt, which stuck around for a little while and was really reliable. So let's see here. We'll drop that little guy in there. Yeah, when you get old, the reading glasses don't really work, and you have to look over them. You have try vision actually. Let's see. Let's pop it here. So. And I hear Peanut talking about some things. Get in here. I made it really hard to get to. Okay. And just tack it on right there. Well, I'm gonna have to solder that side. We are attached. Okay, so that looks like it's in there. So just real quick, let's listen to it one more time. We got the diddle box in because I've already unplugged all the speakers and everything, so it's cool. Just listen to it without the load in series. T-scos and guitars like that, so we're going to leave it a little hot and put it back together and see what we got. Now I'm going to unplug the reverb pan for a moment. Now that we know it's all good and everything, I have the cabinet right here. Let's see. Kind of pop that puppy right back in there, maybe. Now I pulled this out well over 5 years ago, so this is in the way. But I did manage to keep the screws in the same cup during the move. Actually, it's been about 7 years now. Derek Cook gave me this amplifier on his first trip to Meridian, and I've cherished it ever since and been wanting to get it going, and so it looks like now is the time. The screws were pretty odd. They were flatheads, which is just the most bizarre thing in the world. This one I don't have the nut for, but this magnet. It's not important. I can always stick a sorry, a different one on there. I will probably have to find one of those later, but let me get the other two in there. And Hartley, when he put these together, I have the table saw that this cabinet was cut out on in my shop. I traded it to Hartley for a repair on some Macintosh amplifiers last year, or I guess maybe a couple of years ago. I picked it up in my truck when it was snowing outside in Mississippi, which was kind of odd. Now, wing nuts are cool when you got flathead screws. I see why they did that. They're cooler than not wing nuts. Famous last words. There we go. And you can get them to a, let me make sure I got a good front on the amp so that it looks good when I put it back together. Alright, I'm going to go ahead and crank that one down. Now it's aluminum chassis, so you have to be careful not to over tighten it or it'll bow the chassis. And I actually meant to put some little wood supports in there, but I forgot, and it's not very important. It's going to be coming back apart again anyway. I'm going to eventually put the original power amp back in it one day, probably. Let's see. But only when I have another one to compare it to, and you know, some parts built up that I'm pretty sure I can work with. Okay, wing nuts are very difficult to deal with. Crappity crap, crap, crappy crap. Okay. And flathead screws. That looks awful, so I'm going to loosen that. Back up, back it out just a tad. There we go. Okay. Well, that's going to be interesting. So we're going to put the other one up here. Oh, and today, or yesterday, we officially found out that Lori and I are going to be grandparents. Actually for a third time, but now they're going to have them the old-fashioned way, so lots of excitement going on in the Phillips household this week. And we have a Phillips head on the strain relief, so let me get my screwdriver here. Where did the strain relief go? It goes right there. This was a safety feature on amps with two-prong line cord, and I did leave, since it's an ICEpower module, I did leave a two-prong line cord on it. Even though it does have a ground reference. It hums very slightly as a result, but it's nothing that we can't really deal with. Okay, so I want to find the hole where there it was. Okay, that's not it. Okay, there we go. I'm going to put it right there. There we go. And I can point that up so that it comes back out the slot. Okay, now we're good. We're going to put the back on. Usually when you put all the screws in like this, you go back and you find something wrong. So I'm going to put all the screws in it so that I can talk about what went wrong and finish it up later. Let's see. And here's the back. Now this is cool. This is the original serial number on the amp here, and it's 104175. I'm not really sure what that means, but this is the serial plate on the original Peavey amps. We're not going to put the back on yet. Messed up really bad. I'm going to have to put the reverb pin in. Alright, so anyways, I forgot to put the reverb pan in, so went back and installed the old Gibbs Hammond reverb pan. And as you can see, there's almost no clearance to get a screwdriver in here, so I just went in there with a little stubby. You want to leave the reverb pan just a tad loose, so it's got some room to do reverb things. Let's see, I'm thinking this is going to be the input and the output. Yep, because there's a capacitor on the output in the chassis, so put this back in. One more time. Let's see. Alright. Three out of 4 ain't bad. But anyways, really happy to see this one coming to an end, and probably gonna get this one posted pretty soon. And the next video, like I've been saying since day one, is a Van Halen tour chassis from the balance tour that my boss gave me, and I've kind of painstakingly looked around for all the original parts and things like that over several years' time, and found basically everything I need to make it exactly like it was on that tour, aside from the wear and tear that the cabinet took on the tour. It's going to look like a new amp, but it's legit. It should be pretty interesting, and I'm really looking forward to showing that to everyone. And we'll put our strainer leaf back in here one more time. Get this pointed up. The other thing you want to do is plug in the reverb. And that's the reason that reverb usually doesn't work, because you forget to plug it in. Knock that out real quick. And just for fun, I'll stick the back on it. There again is the serial number, 104 or 175. I'm not sure what that means, but it is the serial plate, the serial number. These things were very tightly constructed. And when I get that other wing nut, I can reach in there and put that other screw on through here. So, see, that's the original back, what you would have seen. And all of these panels were cut on a table saw that I have back in my shop that I'm going to refurb and start building period correct cabinets for these one day whenever it gets worthwhile. Still works great. Just had the motor replaced 3 times. There we go. So here we go. We've these are 2 4411s that I put on there that I left that I put to replace the old ones, cleaned up. Of course, it didn't all jive. These transistors are still good, so if I ever go to put the old power amp in, I'll have those there already. The reverb pans in. Got a little bit of the paint splatter that was on there off. I'll probably clean it up better before long. I did keep the original line cord because it was a ICEpower module, and there's no safety issues as long as the head pops out. Let's pop it around here. Okay, and this is it. The 68 Peavey Musician head, the first official model that for MI that Peavey made. They may have made a few more PA amplifiers than they did of these, but we'll plug it in and kind of go through what it sounds like a little. Now I'm going to put the dummy load back in series with it. It's pretty cool to be able to look at it on the scope at the same time. Put our light there. Okay, and I'm gonna get my new favorite test guitar that I bought. Actually traded to Jeff Williams recently. So just going through the. Here, let me load it a little bit more with a. Well, I'll do one of them against the 16 ohm. Doesn't matter. It's not too loud. It's about 25 watts. So with 2 single coils, let's see. We'll start with everything on 5. You can't see the scope probe fell off here. So there's my pick we just made out of an old driver's license. Me and my son, I'll show them how the pick machine that we have works. I usually won't use a pick on these videos, but this is I have one, so I'm going to use it. Clean. And we're in the 2 single coils quack position right now. We go just to the bridge. That's a bridge single coil, now bridge humbucker. Now we'll go turn the volume up to about, well, we'll leave that on 2 or whatever. Okay, and we'll turn the lows up. That nasty distortion is a transistor just coming out of bias. You can reduce the lows or just cut the output to it by just simply making it a single coil. Obviously this amp was designed with single coils, so there's the treble. That's on 5. Goes into some really bright territory. Now we'll turn those back to 5 and go up with the volume here. Just a nice round, warm, fair sounding amp. You can do a lot with it. Pretty crap going on there when you cut the output up, which is go back to the black side. So when you hear something like that, sometimes maybe you think, well, what would happen if you had more of that? So let's go on and cut it up. Sometimes more is good. Single coil there. Alright, so now this is a pretty decent rock tone right here, wide open with some treble and some bass. And the ICEpower module, it clips kind of like an old solid state amp. It clips a little more musically than an old solid state amp does actually. The nastiness and funkiness that you hear is all preamp, discrete preamps that weren't meant to have signals that large going into them. And like I said, I know this particular amp was designed with single coils, moderate output single coils. So let's see the reverb channel here. We'll just go to all 3 on 5 like we had there before. Now the hum is for the single coil. Let's just go to the, for fun, let's just go to the neck humbucker here. It's a nice frothy tone right there. See bridge, humbucker. If you push hard enough, you can get past the breakup. Now this preamp that stage that's making the funky noise was biased a little higher than this one was, so there's a slight difference in where it makes that that's in there. That's where you hear that happening. And aside from that, it's okay with a bridge. Alright, so let's cut it back down a little more. There's a little DC on that pipe, which is why it makes that scrubbing noise, which we're not going to fix. So the reverb here. Wow, it's like a canyon. So that's on 5. That's on 10. Emitter and collector resistors in that little power amp circuit driving the pan, so it's got a lot of odd crossover distortion. So just, in general, it'll be less than that, but just like it on about 2. Now the tremolo, like I said, it was really weak. It's most effective with the depth on 10. There's the rate all the way down, and all the way up. Basic rudimentary transistor bias modulation circuit, so it does what it does, and I could put the LDR in the dark. Maybe it needs a new element in the LDR because it had a neon and a C2S cell bundled up with a piece of electrical tape, so I mean I'm sure there's some improvements to be made, but as far as basic sounds you get out of the amp, you know, the clean's the clean. It would make a great pedal platform, you know, as long as you had some control over what was coming into it. The EQ is real dynamic. You can the treble, and the treble can just get to the point where it blows away everything. The cool thing about these old Peavey amps with the active EQs is that they go too far, and so then you back down, and they work out. So that's pretty good. More fun with single coils. Opens up really nice. Do sort of a feedback test on it here. Let's try it. valid amp, good sounds, definitely a keeper. I'm gonna keep it in my collection for sure. Now the other thing is that the older Peavey heads, the first generation ones like this, they didn't have this brushed aluminum. They had an actual chrome plated logo. So my next thing is to either polish this one to be chrome or try to find the original, which I doubt is going to happen. But anyways, that's just a quick run through of what this amp does and what it's all about. And stay tuned for some more similar things from Peavey coming out. Maybe if you're into NAMM and the things going on at NAMM this year in January, check out some of the stuff that we're coming out with. And you'll, I think you'll be surprised at what you see. And definitely stay tuned. We have a whole pile of stuff here to fix. Some really cool things. Don't show the Christmas present pile yet. It's fine. And then we'll be back. And thanks for watching. Hit like and subscribe and tell all your friends who might be interested. And we'll try to do the Van Halen amp next. Thanks for watching.